started just yet. I'm going to keep playing around with this. But, as we hang out, feel free to say hi. Let me know how you're doing. Let me know what you're working on Macs. I've got a package up, which I'll talk about more in a moment, but it's a Macs package called the MC Movement Studios. That gets pretty wild. To get that one working. That's cool. There's that one. Yeah, this is a great one. Yeah, pretty wild. Let's see. All right, everyone, let's get started for tonight. I like to begin by showing off various tools. And what we're looking at right now is a package in the Macs Package Manager called the MC Movement Studios. And it's tagged as being by Cycling74, the developers of Macs, and Dylan Bastian. And I know that while he was working on this, Dylan Bastian was showing it off a lot, and he's still doing a lot of work exploring these concepts. But specifically, this is a sort of collection of patches and tools that all deal with emulations of particle physics in different ways. And so if we look at, say, one of these examples, MC magnetism, which I was looking at before, where we start a sound, like in this case, it's a drum loop. And then we can create this particle field and begin to make sort of these weird and wild delays based off of it. So I'll turn that particle field on and try out some different sounds. You can see that it gets pretty wild. He is actually emulating uh, the creation of particles and the movement of particles through at least through a two-dimensional space, as controlled by magnets or magnetism and gravity and flow fields and wind and all sorts of different things. And then sort of wrapping those particles' coordinates and information onto whatever parameter he wants to, really. And in this case, he's sort of creating a really weird filter delay line using this particle system. And it's a really wild toolbox. It's got a lot to it. He's still doing more work. Dylan Bastian's still doing more work with this, as far as I know, and is actually making some pretty cool synthesizers, I think, right now that leverage this sort of particle system simulation. So a lot of fun to check out. Definitely worth your time just to play with, and if you can find some fun ways to incorporate it into one of your projects, then all the better. So let's sort of quickly leave the introduction and get right into the bulk of what we're going to be doing today. For the record, where I am starting today is where we left off on Tuesday. If you want to follow along but you couldn't watch the Tuesday class, do keep in mind that I post all the patches that we use on Patreon, and those patches are free to download and follow along with until the class ends. So you can go over to my Patreon page right now and grab the files and then get them unzipped and get started. And just as a quick refresher, if you get the file off of Patreon and unzip it, it will create a folder, and we do want all the contents in the folder to stay together. Still can't access Patreon. Love to access the patch. I'm still not sure why it would give a 404, unless the Patreon URL that I gave is weird or off. But if you, let's see, I don't know. Let me look up Music and Tech. So the Patreon site is Music and Tech Explained, and it comes up on Twitch right away. Let's see if I can follow the link. If you go to my Twitter page, you can also get to it from there. Let's see. Yeah, you should be able to. Another way to find the Patreon page itself is via Twitter. That's the exact URL. Let me see if I follow that URL, what happens to me. Oh, look at that. Music and Tech Explained. So that doesn't work. That is very, very good to know. So let's see. What I'm going to do is I'm going to just go ahead and post this link in the chat log, because that link should take you directly to where you need to go. And then I guess I'll have to look over that URL and make sure that I know what's up there and I've got it right. And then if anybody else comes asking, please do point them to that link, because that'll get them right to where they need to be. Okay, so thanks for bringing that to my attention. I'll double check that as we go. But when you download the files for tonight's class, it's going to be a zip file instead of a single max patch, and that zip file needs to be fully extracted into its own folder, and everything in that folder needs to stay together. And that's because we're going to be making reference to this collection of waveforms by AdventureKit, the AdventureKit waveform collection, which we looked at on Tuesday, as we looked at how to put together paths to various folders on our system to find, in this case, waveforms that we wanted to load into our custom buffer. Right? We finished off the class by creating this interface where we can select a folder from this AdventureKit collection, and once we select the folder, it populates that list with waveforms. And then we can select any of those waveforms, and it will update the timbre of what we're working with. And it was fun because we've got like thousands of waveforms here, and it's all generously made by the creator AdventureKit and distributed for free. So that's where we're starting today, and we're going to make a lot of progress from here. We're going to begin by discussing encapsulation. Again, we've talked about encapsulation in the past, but there are always multiple ways to determine sort of how to codify cleaning up our work as we go, and how to think about what we need to do to clean up as we go. And then once we'd finished that, we're going to add an ADSR envelope, an attack, decay, sustain, and release amplitude envelope to our wave tilde output, which will allow us to actually control the volume of the pitch over the duration of the note. So we should have the note start and stop, and we should have the amplitude change as the note begins, as it sustains, and then as we release the key. Now, in the first unit, we did a very, very, very simple version of this, where we grabbed the velocity out of the K slider, and if the velocity was more than 0, we would start the note, and if it was 0, we would stop the note. We're going to do something a bit more elegant and a bit more customizable tonight. After that, we're going to look at how to actually connect MIDI hardware into our patches and how to read MIDI data from the hardware in our patches. And so tonight, I'm going to be using my Arturia Mini Lab, which I've displayed a couple of times, but I finally actually get to use it in the stream. So we're going to look at how to set up MIDI hardware, and we'll use that to actually make our synthesizer playable. So we're going to make a lot of progress today, and I'm just going to start pushing through. So first, I want to clean this up, because if we're going to have 3 waveforms, right now we have 1, but if we're going to have 3 waveforms, and we're going to be able to select a custom waveform for each of them, we could see how duplicating all this code 3 times would really, really rapidly cramp our patch, right? And suddenly it would take up way too much space. So we want to avoid that cramp, and what I want to do is I want to encapsulate what makes sense to encapsulate. And I thought about this for a little bit, and I realized that what I really have is this sort of duplicate chunk of code from the types through the folder, the U menu, and the sprintf and the to symbol. And what this chunk is doing is it is taking in an absolute path, which we make up here, but the chunk takes in an absolute path, and then based on the file type that we give it, spits out a collection of files that are found in that folder. It then allows us to append the name of that file onto the absolute path that we have brought in, and wraps that up into a string. So that's the piece of code that we replicate twice, and so it makes sense that we want to make that the piece of code that we encapsulate. So I'm going to select the types message, the folder message, and you know what? I'm actually going to start, instead of starting here, I'm going to start at the top level, because we see the same thing happening here: types, folder, U menu, sprintf, bang, and to symbol. I'm going to keep the comment outside so that we can sort of tweak and customize that comment a little bit more. But I'm just going to begin by encapsulating, which I do with the shortcut Shift-Control-E or Shift-Command-E on Mac OS. And we can see now, if I go into that, we have that good to go. And what I want to do is I want to make this into its own maxpat file. Because remember, if we make a subpatcher into its own maxpat file, then we can view the contents of that subpatcher with the bpatcher object. We can't do that with the basic subpatcher. It has to be its own file. So with that subpatcher that I encapsulated open, I'm going to go to File, Save As. I'll make sure I'm in that same folder as the top level patch. Right? So we want it to be in that exact same folder. And I'm going to give this its own name. And again, we can name it whatever we want, but we want it to be idiomatic. So how about Menu Builder? I'm going to keep it as one word, because that makes things easier. I'll do lowercase menu, uppercase builder, and I'll save that file. So now in that same folder, I have my main patch, and I also have the menu builder patch, and I can open that up from here, and I can work on it more. But I'm going to go ahead and open it up in our main patch with the bpatcher. So remember, to load the view in, we make a new object, so a bpatcher, and the argument is the name of the patch within the path. So that was, what did I just call that? Menu builder, right? And as soon as I hit return, we now have our new view into that patch. And I can manipulate that by right-clicking on the B patcher, going to Object, and hitting Open Original. Okay, and the reason why I'm doing it this way is simply so that I get updates immediately in the main patch, but I could have just opened up that patch separately. Either way is absolutely fine. And you can see that what's coming in on the left-hand side is our absolute path, and I've just sort of figured this out so that we're starting with the absolute path already understood. That's why we didn't wrap up the absolute path into this. So it's assuming that an absolute path is coming in, and that's what's coming into the left inlet. And what's coming into the right inlet is actually just a bang that's loading the types. Now, we don't need that bang. We don't need it to be external, so I can just get rid of that inlet and replace it with a load bang, which will do the same thing. So next, what I want to do is I want to make the interface version of this, the user interface version of this. So I'm going to switch to the presentation view. And the U menu is already in the presentation view because when I made the file, that object had already had that option selected. So what I'm going to do is I'm just going to move it up to the top left corner, and that way it will be aligned with the top left of the B patcher. But there's one other change I need to make. I need to tell this patch that I want it to open in presentation. So I'm going to go to the inspector for the patch, not for an individual object, but for the entire patch. And I'm going to scroll down until I find Open in Presentation. I'm going to toggle that on. I'll close out the inspector. I will hit Save. And we can see that instantaneously the B patcher updated. And that's sort of why I wanted these to be up at the same time. Now, if I close this out, come back over here, I can hover over the B patcher and see I have one inlet, which is expecting the absolute path, and one outlet, which is spitting out the path merged with the output from our U menu. So I can replace now this subpatcher that I made with the cleaned up B patcher. All right, and then I can keep my comment over there. I don't need that hooked up. In fact, I don't need the patcher at all. And you always want to double check your work, just make sure you didn't break anything. So I'm going to load the AKWF back in. I can see that I still have that collection, and it did in fact send out the information onto the next folder. And if I bring the volume up, okay, so things are working. That's good. But I'm not quite done with that encapsulation yet because it's not flexible enough. Remember that I brought that types message into the subpatcher, into the, not the subpatcher, into the B patcher, the new max pat. And the types for the top level I set to fold, so it would find the list of folders. Where we're looking for the AKWF folder, and its first level inside is just a gigantic collection of folders, and each folder has our waveforms. That's why we're doing this in two phases. And so the first menu we want to fill with folders. The second menu we want to fill with waveforms. And I want to make sure that the types can be variable. So let me show you how we'll do that. I'm going to open the original patch again. So again, that's right-click on the B patcher, go down to Object, Open Original. And I will go back into Editing View, Patching View, and unlock it. And remember that B patchers can receive arguments, just like regular max objects, right? Like in the phaser object, it has an argument of 440, which is starting frequency. We can define custom arguments within our patches using a specific symbol combination. Wherever we want a message to be replaced by an argument, we use the # or the hash, and then the argument number that we want to set to that. So this would be the only argument we need for the subpatcher. So I'm going to do #1 for argument number 1. I'm going to do one more thing. I'm going to make one more change before we're finished with this encapsulation altogether. I'm going to make a new message, and I'm going to have that message be clear. Now clear, when you send clear to a U menu, it wipes it out. And the reason why I'm going to start with the load bang clear is because I don't want by accident, this menu to be populated with something else. Remember that my idea is that even though we're starting with the Adventure Kid waveforms, you should be able to plunk in whatever collection of waveforms you have and it should work. And I just want to double check. I want to make certain, I want to be certain that this isn't working because by default that U menu had my Adventure Kid stuff in it. So it's sort of a test, right? But it also makes sure that it's dynamic. So I put that clear in, but that's not the most important part. The most important part is the message types followed by the #1. So whatever I set as my argument into the B patcher will replace that #1. So what I want is not types #1, I want types fold. So I'm going to save this again. It cleared this, and now if I try it, it's still working because fold was the last option I set. But what I really want to do is I want to go into the inspector for the B patcher. And in the, I'm just expanding this so we can all see. So this is the B patcher inspector. In the last section, we have the name of the file, the name of the maxpat file, and then the arguments for that. So the argument for this one is fold. Fold is the 4-letter abbreviation for folder. I type that in, and I will double test. I will do the load bang. There's my collection of folders. So now I have something that's flexible enough to work for both of these cases. And what I can do is I can just make a duplicate. And instead of doing all of this code, everything from here, let me see if I can get this stuff out of the way. All of this code is not necessary anymore. I can just send the output of the first folder maker into the second folder maker, and the output of the second folder maker into the replace. And all I need to do with the second one, remember that the first level is folders, the second level is waveforms that are, in this case, specifically .wave file types. And we need a 4-letter abbreviation for the file type. And in this case, it's going to be all uppercase WAVE. And that's our file type 4-letter abbreviation for the .wave extension. And now I just want to double test one more time. I'm going to load bang. And it did populate all the way down. If I choose the birds, I can see that went into the next subfolder, gave me a collection of birds, and that's going on into our buffer. And I kept my comment aside so that we could have those flexible comments. And this is a much cleaner view in. And as we add oscillators to our collection, as we move this from a single oscillator to 2 or 3 or however many you want, having those menu populators just be available to us with a copy-paste is going to be really nice. But for now, just one more check to make sure that's still working. So there's birds, 7, 9, 13, 14, clarinet, 2, 5, 11. Good, okay, that's working. So that was some nice, thoughtful encapsulation. We only got what we needed in there, and I can do some more cleanup now. That prepinned no longer doing anything. I can just get stuff organized, lined up, and I'll do my shortcut. I'll highlight everything that I want to be aligned vertically, and I'll do Control-Shift-A just to double check the alignment. That did work out just fine. And I can move this down a bit more, should I want to. So before we go on, if anyone's got any questions, feel free to ask them in the chat log. And there are other things I can do to clean this up. So for example, I could move that set wave message over there so I don't need this sort of stray set message anymore. Hanging on by the seat of your pants. Yeah, good. I'm trying to move pretty quickly tonight while still being thorough, right? Here we go. So this feels quite a bit cleaner now. So now I want to get to the second topic, and I actually misordered these. The second topic tonight's going to be the ADSR amplitude envelope. And this is a brand new topic I haven't covered in the class yet, so I'm going to spend a little more time on it. Because the concept of an envelope is one of the critical notions at the core of understanding the building a nuanced and complex synthesizer. So an envelope is sort of a catch-all term that refers to something that controls a parameter over the duration of an event. And in the case of synthesis, typically the event is a note. The note starts, and at some point the note stops. And so an envelope, in this case, will control some parameter over the duration of a note's lifetime. And we see envelopes that get used for all sorts of parameters. We can have it control like FM frequency. We can have it control filter sweep. But the most commonplace and the most often used place for an envelope is controlling the volume of a note over time. So now, if you think about it, the volume of a note over its duration has a massive impact on how a note affects us as we listen to it and a lot of the qualities of the note. If you think about playing a piano, right, which I'll start with because I got my little keyboard here. When you play an acoustic piano, your finger strikes the key, and that key strike causes a hammer inside the piano to come up and strike a string. There's a little bit more to it with dampers, but let's just think about a hammer striking a string. Because that hammer strikes the string so forcefully and quickly, the note almost immediately reaches its full volume. Right, so we get this quick strike up to full volume. And then because a piano is different from like a violin, you can't sustain a piano note. So it has this sort of natural decay or drop off in volume over time. And that's a lot of what goes into making a piano sound like a piano. Now, if we go to that other instrument I mentioned, a violin, we have a lot of different ways to control the volume over the duration of the note. So, imagine you have the violin, you have the bow, and that bow is really going to control volume. And you could, for example, very gradually increase the velocity of your bow stroke, which would bring up the volume as a swell. So it may start quiet and then swell up to full volume. And then you could just keep sustaining that note with the bow stroke, right? And then when you're ready, you could release the bow. And because when you release the bow, you have the ability to damper the string with your finger, you could conceivably have that note stop on a dime. Or you could let that note kind of decay as the string just naturally loses its energy and the vibration. So, not that amplitude alone makes a violin sound like a violin or a piano sound like a piano, but it's one of the most critical features to giving an instrument its own unique quality. So an envelope is what's going to replicate that process for us. And there are a lot of different ways of building envelopes. We can sort of manually make it piece by piece, but there is a object in Max called the ADSR tilde. And if we look at the description of it, it says ADSR envelope generator. Now, the ADSR is an abbreviation for the four components to this type of envelope. The ADSR envelope is a classic type of envelope, and it takes place in four pieces. The attack, which will be the beginning of the note, the decay, which comes once the beginning is over, the sustain, which will be the note over its duration, and then the release, which will be the value at the end of the note once you've lifted the key. So by defining values for each of these points over the note's duration, we can affect what I was sort of talking about before. So the ADSR tilde allows us to create an ADSR envelope with just a single object. Now, what the ADSR tilde is going to output is a number. And traditionally, we use the numbers 0 and 1, right? And 0 will be, or 1 will be a note's beginning. So when we give it a 1, it will begin, it will ramp up to a value of 1. And when we give it a 0, it will go to the release portion and it will ramp down. And so it's going to output an amplitude that we can multiply our oscillator by to get a final volume. And I'm gonna go into a lot more detail on this in a moment, but I just want to do the basic setup so that we can see how this works. Remember that when we built our very, very basic envelope in the first unit, we multiplied the oscillator by a set value with the multiply tilde object, and we gave it an initial value of 0, right? If you multiply a signal by 0, you get 0, which means that you're going to have silence. If you multiply a signal by 1 or anything greater than 0, you're going to get that value, in this case the audio sample, scaled by whatever number we give it. So it'll be maybe quieter than the original volume, maybe the same amount as the original volume, maybe louder than the original volume. A 1 would give us the same volume. Anything less than 1 would be quieter. Anything larger than 1 would be louder. But I've replicated the most important part of this. We have our wave tilde going out, but it's hitting the multiply tilde 0 first, which means it's going to be quiet. Right now, if I do anything, we don't hear anything because it's all zeros. And I'll bring in a number tilde so we can see this. It's all zeros, right? 0 or negative 0, even though our initial waveform is still spinning. Once it gets multiplied by 0, it's empty, or it's quiet, silent. Now the ADSR, as I said, if I give this a 1, it will ramp up to 1. And if I give this a 0, it'll go back down to 0. So I'll do this really quickly. 1, 0. Now it actually didn't go up to 1. It went to 0.75. And we'll talk about why in a bit. But in its default state, it's just basically an on-off toggle. The note begins, the note ends. And we can still control it via a similar process to what we did in Chapter 1, where I made a comparison object greater than 0 and used the velocity output of the K slider to get our velocity. Now remember that a velocity of 0 is the MIDI message for note off. Perfect for us, right? Anything above that will be note on and the velocity of the strike. So when I do a comparison of greater than 0, if I get a 0, it'll be 0. If it's anything else, it'll be 1. That's our basic toggle. But remember the K slider, in its default state, doesn't actually spit out zeros. It spits out a MIDI pitch and a velocity, but there's never a note off event. So we need to change how the K slider functions using the K slider inspector. We did this in the first unit, but it's been a while. So I clicked on the K slider, I opened the inspector, and in the display mode, I'm going to switch from monophonic to touchscreen. This is a lot of fun if you're using like a laptop with a touch capacitive screen. But now, when I click the K slider, we'll get a note on, and when I release it, when I release my mouse, we get a velocity of 0, which spits out a 0 from the comparison, and our note stops. So at this point, our ADSR tilde is working actually the same way, almost the same way, at least as we can see it, to the setup that we had to control volume in our first unit. But this gets so much better than that. I'm going to open up the help file for this because I want to show you a little bit more. Let's see, I'm getting on another tab here. Yeah. Let me see if I can just turn that volume down so we can look at the basic tab. So let's talk more about an ADSR now that we have it set up and functional. All right. So remember that an ADSR says we have 4 components to the duration of the note: the attack, the decay, the sustain, and the release. Now, 3 of these 4 values, attack, decay, and release, are measurements of time. And we can see that in the help file because it says attack milliseconds, decay milliseconds, and release milliseconds. Only one of these has anything to do with volume, and that's sustain. So what happens is when we send in a 1, it will trigger the attack component of the ADSR. And that says, from the time we get the 1, how long does it take for this note to ramp up to full volume? Think back to the notion of the piano where you strike the key and it starts almost immediately. So the default attack time is 10 milliseconds, very piano-like. So at some point the attack will end, and the note may keep going, and actually by default it will keep going until you release it. but it might not necessarily continue at full volume. So we'll call full volume 0.1, or sorry, not 0.1, 1.0. So in other words, we're multiplying everything by 1. We haven't changed the volume. It's at full volume. After the attack finishes and it reaches full volume, it's going to make its way down to its sustain volume. And sustain volume might be full volume, or it might be less. Think about, go back to the violin idea, and maybe we have a note that goes, ya, right? It's a very sort of arresting start with a lot of impact behind it, and then it comes down in volume. We can do that by using a sustain value that is less than 1. Our sustain value could go above 1 if we really wanted it to, but traditionally it's 1 or less, right? And if we think back to the piano example, remember that there's nothing to allow a piano note to sustain indefinitely if you're not using the sustain pedal. So the piano is going to decay and decay and decay until it's totally quiet. So the sustain in a piano string would be 0. But there will be a decay time, how long it takes after the attack is finished for the note to reach its sustain value. Finally, at some point, the performer is going to lift their finger from the key, or they're going to lift the bow from the string, and there will no longer be anything that could potentially sustain the note. And so the note will be released. All right? And when we get to the release, when the key is lifted, what we want to send to the ADSR is a 0. A 0 message tells the ADSR to start the release component. And the release component is a measurement of time, again, how long it takes after the note has been released for the volume to go from its current value all the way down to 0. So that's a lot of information to keep in your head. And so what we can do to help a little bit is we can just grab some code from the help file. So watch this and keep this in mind. All the help files are max patches, and you can grab anything by unlocking them and just doing what you want. Now you have to be careful because you could accidentally, right, cut some code out, change some code, and then, I mean, it will ask you if you want to save, but you might end up saving your help file and breaking it. So we want to be careful when we're working in the help files. But I'm going to grab the attack, decay, sustain, and release, and I want to notice that these values can be plugged into the other inlets. The 0th inlet is for start and stop, but the 1st, 2nd, 3rd, and 4th are for attack, decay, sustain, and release. So I'm going to grab all 4 of those. I'm going to Control-C or Command-C to copy it, and I'm going to bring that back in with Command-V or Control-V into my patch. And now I need to make some room because this is getting a little cramped. So maybe I'll move all this over and bring my K slider out a bit too. I just need, yeah, I did not do that very well. Shoot. Let's see, attack, decay, sustain, and release. Bring that over, and then attack, decay, sustain, and release. There we go. I messed it up a little bit, but I got back. And then I'm going to plug those into the corresponding inlets. And if you forget, just hover over the inlets. I can see that the first inlet, not second, the 0th, first inlet says that it's expecting attack, second is decay, third is sustain, and 4th is release. And let's just test this out. So I'm going to plug these in. All right. And now I'm getting my start-stop from the keyboard. Let's start with the defaults. The defaults are attack time of 10 milliseconds, a decay of 1,000 milliseconds, which is 1 second. Now remember that is just truncated visually. Maybe not. Did I do that back? 1000. Why is that truncating? Oh, that's because I moved everything over. So this is actually... This is how it should work. This is the attack. And we'll talk about what's happening here if we have time, but it's an easy thing to fix. So I'm just going to go ahead and fix it. Attack, decay. And this is because I moved over the message boxes or the number boxes. So if you're not getting that error, then you're perfect. You're good. So we have a default attack time of 10 milliseconds, a default decay time of 1,000. We'll do a sustain out as default, which is 0.8. and then a release of 10 milliseconds. That's the default. And let's just test it out. It's very snappy, right? So now let's make a really long attack time. Let's make the attack time take 2 seconds. So it's going to swell up in volume over 2 seconds. So you see that you heard that swell, and it's going to stay at that volume until I release it. And then because the release is so short, it just sort of snap is away. But I'm going to increase the release time. Let's set the release time to be 2,000 milliseconds or 2 seconds. So now I play the note, it swells in, I release the note, and it gradually decays out. So we can see that we actually have a lot more control over the amplitude of our note, over its duration, when we use an ADSR. So I want to show you just a couple of other examples with this. If we wanted to emulate the piano, we could do a short attack time, so we'll go back to 10 milliseconds, and we'll do a long decay time. A good piano, the string will take quite a long amount of time to fully decay. And it's not going to be a linear decay, it's going to be logarithmic. This decay will be linear, so I'm not going to get to a real piano-like sound. But let's just give it like a 4-second. Oh shoot, I'm still in attack. Let me undo that. Let's give it a 4-second decay, so that'd be 4,000 milliseconds. And we want the sustain to be 0. In other words, a piano, you can't hold down the key to keep it going if you don't have the sostenuto or the damper pedal on. So now if I play it, because the sustain is at 0, it begins instantly and then gradually disappears even though I'm still holding the key down. Now, if I release the key before the decay portion finishes, it will skip the rest of the decay and just wherever it is volume-wise, it will start the release from that volume. So if I do a quick piano note, and a piano would have a very short release time because the damper stops the key. So 10 millisecond release time. So I play the note, and even though it's decaying, as soon as I release the note, it finishes. So there's our piano emulation. Another neat trick that you can do with the sustain of 0, we can emulate the sound of a reverse waveform, like if you took a guitar pluck and reversed it. If you think about what would happen with a guitar pluck in reverse, you pluck the note of the guitar, it starts instantly and it decays, right? If you reverse that, you would get a swell in, and then when the pluck started, you would actually get a short cut out. So to do that, we want a long swell, a long attack time. Let's do 2 seconds or 2,000 milliseconds. And then a decay of 0, because we want it to swell up, and then a sustain of 0. So it's going to swell up and then just drop out. So 2,000 attack, 0 decay, 0 sustain. And if we wanted to shorten that, let's try an attack of 1 second. So instead of 2,000, let's do 1,000. Now we're getting a click because it's literally going from its full volume directly to 0. And whenever you have a sudden leap in amplitude, you will get clicks. So maybe instead of a direct leap to 0, let's do a decay of 10 milliseconds. It should still give us the same effect minus the click. Yeah, that cleaned it up. Okay, so while we're on the ADSR, before we move on to the MIDI hardware, I wanted to show a little bit more about how the ADSR works because we can get actually a little more nuance out of this. So let's pull up the number tilde again. I want to visualize what's coming out of the ADSR. So it's kind of hard to see. Let's set the sustain to 1 just for a while. And what we'll see is that what happens is it swells up to some value. We've been saying it's 1. And then it goes to its sustain value. But the way that the ADSR tilde actually works is its full value, amplitude, is whatever number it receives. So if it receives a 1, it will ramp up to 1. But if it receives a 2, it'll ramp up to 2. Now, why is that meaningful to us? You'll see in a moment, but just to demonstrate, I'm going to give it a 2. And we'll see that it ramped up to 2. And this is actually an interesting thing to observe. Now, this says that the sustain is a measurement of gain from 0 to 1, but it's actually a gain multiple of the number we gave it. So if I set the sustain to 0.5, let me end that note, and then give it a 2 again, see how it actually only went up to 1. Right, it actually went up to 2 and then dipped down in 10 milliseconds to 1. So how is that useful to us? Well, if we think about a MIDI controller or just performing in real life, we always get more nuance than just a note is playing or it's not playing, right? At the very least, we can say that the note is louder or softer. And the MIDI protocol was developed with this notion in mind, that when we perform, we don't just play a note, that there's additional information in there. And the MIDI protocol doesn't use volume in its understanding of sound. It doesn't. It uses velocity. And velocity is actually smarter than volume, because if you think about beginning a note with more or less velocity, I'm thinking piano, right? There may be more changes or more differences than just volume. Velocity will often impart volume, but it will impart other things as well. If you're playing an acoustic piano, like a Steinway 9-foot grand, and you really strike a key, not only will you get a loud note, but because the hammer struck with such force, you'll hear some of the hammer strike. But if you strike it gently, not only will it be quieter, but the hammer will not strike loud enough necessarily to hear it. So velocity imparts more information conceptually than volume. But for our purposes, we're going to think about volume. Now, our MIDI controllers and this K slider both output velocity, so we can use that. And velocity outputs on a scale in MIDI between 0, which remember 0 is our velocity for off, and 128. So the way that this works is the higher I strike a key, or the higher I click a key on the K slider, the louder or the more forceful the velocity will be. So if I click the key at the bottom, and I was talking and coding and I wasn't telling you what I'm doing. I'm going to view the velocity by making a message object, and I'm going to send the velocity output, which is the right outlet, into the right inlet of the message object. That's how we view output in a message object. So if I press the key near the bottom, we get 3. 3 is a very low number, so very, very gentle velocity. If I move up, then we get higher and higher values, and the max value we can get is 127. All right. So that means that we actually have 127 different potential amplitudes, with a 0 being off, so I'm not counting that. So now we could send 0 to 127 into our ADSR, but that's going to, if we send in an ADSR value of 127, we're going to break our speakers, we're going to break our eardrums. So what we can do instead is we can take that output, the 0 to 127, and divide it by 127. And I'm going to do something that is critical. Whenever we deal with numbers, we need to think about data types. And there are 2 number data types in Max. There's integer, which are whole numbers, and floating point. And we're going to, by dividing anything by 127 here, we're going to end up with a floating point value. And so we want to make sure that we put in a dot after the 127. That's how we initialize the division operator to receive output and process floating point numbers. So divide by space 127 dot. That's critical. And if I plug that in and look at the output there, so again, I'm going to take the outlet, plug it into the right inlet of a message box. I could do this with floating point number boxes also. Either one is fine. Now, I'm getting a value scaled between 0 and 1, which is awesome for our ADSR. I can get a loud volume that's going to be loud but not destroying our eardrums, right? So what I'm going to do is, instead of this greater than 0 comparison, I don't need to do that comparison anymore. And I'm going to clean up a little bit. Clean. I'm going to put in whatever value I get from this division into the ADSR. A 0 into the ADSR will trigger the release, but anything above 0 will trigger the attack. It'll just be scaled by the number we give it. So if I bring the volume back up and I hit the key very low, very quiet. Higher, a little louder. Higher still, even louder. And at the top, we get full volume. And then we had that quick dip down. That's sort of the weird sounding part. So that's a really good thing to understand about the ADSR. It's kind of in there in the help file, but you have to look around for it. Okay, so at this point, we have everything that we need to control this note over its duration in software. It's actually a very easy process if we know the objects to have this work with our hardware as well. So I already have my Arturia Mini Lab plugged in. I had it plugged in when I opened Max. I believe that you can plug it in after you open Max and it will be fine. But there are a couple of key objects we're going to use. One of them is MIDI in. So I'm making a new object. I'm putting this above the K slider for reasons that we'll see in a moment. And I'm typing MIDI in to make the MIDI in object. Now the MIDI in object is sort of like the folder object, interestingly enough. Remember from last lesson that the folder object populates a U menu with the names of contents of a folder. The MIDI in object populates a folder with the name of MIDI devices that you have connected to your computer. And there's a little bit of code that this is designed to work with. And so what I always do when I make a MIDI in object is I go to the MIDI in help file. So I'm going to open up the MIDI in help file. And this is the chunk of code that I want. Actually, I misspoke. It's not MIDI in that populates the U menu. It's MIDI info. But either way, what we want is the MIDI info to populate our U menu. And then we want to tell MIDI in what device to look for. And then the MIDI in will listen. It will actually spit out MIDI data that we give it. So this also, the MIDI info wants a load mess of 0 to load the assortment of MIDI devices when the patch opens. So I'm actually going to grab load mess 0, MIDI info, this U menu, and the MIDI in object. We don't need the print, but we do need these four. And then I'll copy that. I'll close the help file and I'll paste that in. This is just like how you start. You could build it manually, but it's just faster to copy paste. So what's happening is you can see it's already found my Zoom, which is my audio device. And then here's my Arturia Mini Lab. And if we want to see what's coming out, this is raw MIDI data. It's a stream of data. And if I play my keyboard, you can see it's just spitting numbers out. And it's not doing it in a very intelligent way. It's just whatever numbers it gets, it spits out. So what we want is an object that knows how to process the MIDI data. And that object is called MIDI parse. Now, MIDI parse is complicated. It's got a lot of outlets, but it only has one inlet, thankfully. And it expects raw MIDI data in. Thankfully, that's what MIDI in gives us, raw MIDI data. So every outlet of the MIDI parse, so what the MIDI parse does is it takes the raw MIDI data and then it understands that certain messages mean certain things. And it will split those certain messages to come out of the different outlets of the MIDI parse. So we have an outlet. I'm going to move this all up just a little bit more. We have an outlet for note on and note off. That's what we want. It's a list with pitch and velocity. Then we have polykey, which is a list that contains key and value for pressure, polykey pressure. We have one for control change. And it goes on and on. The important thing is that we need this first one. But we're not quite done. We can't just take the output. Let's see what it gives us. Now if I press a key, I get two values. The first value is the MIDI pitch, and the second value is the velocity. And notice that when I lift my finger, which I'm doing now, I get the same pitch, and I get a velocity of 0. Remember, that's how MIDI says we're done with the note. But here's the problem. The left side of this list is what we want to send to the M to F. We want to convert that MIDI pitch to frequency. The right side of the list is what we want to send to this divide by 127 into our ADSR. So we have to split that list up. And this is another new object. I know we've been going through a lot of these in the last couple of classes, so thanks for keeping up, and I know it's a lot. But the next object is an unpack object. And its whole job is to unpack lists of stuff. So you initialize it with the word unpack, and then it can take however many arguments you want to give it. Each argument will be the data type for the element in the list we're going to give it. So this list has 2 elements, and they're both integers. MIDI data comes in as integers between 0 and 127. So the data type can be initialized by just giving it an example of that data type. I could put in 0. I could put in 100. It's not too critical for what we're doing right now, but what I wouldn't want to do is something like foo, because foo is a string, and what we want to unpack is an integer. So I'm going to initialize it with an integer 0, and then another integer 0, and this is because we're sitting at 2 values. And so this is now initialized to say, give me a list of 2 values, both of which you're telling me are integers, and I'm going to split those into 2 separate messages and spit them out of separate outlets. So I'll show you that. I'll make a couple more message boxes and connect them, and then I'll hit my MIDI keyboard again, and I've got pitch out of the left outlet of the unpack and velocity out of the right. Okay, so now we have our messages processed and ready to go, and I could, if I wanted to, just send the left outlet onto the M to F and the right outlet onto the divide by 127. But what I like to do is I like the display that the K slider gives me, and the K slider is actually built to expect MIDI pitch data in the left inlet and MIDI velocity data in the right. So it's already sort of designed for this workflow. Really having a hard time aligning that. There we go. So now if I press my physical keyboard, it gets received by the MIDI-in, which is looking for the keyboard. The MIDI-in spits out the raw data, which gets processed and parsed in the MIDI parse into a MIDI on and note off message, which then gets split into its subsequent values, the pitch and the velocity, and that gets sent on to the K slider. Now, I do want to talk, before we finish the discussion on hardware integration, I do want to talk about one really important thing that I have to bring up. With Max 8, C74 integrated a similar MIDI mapping workflow that Ableton Live uses. And it's super cool, but it's not a one-size-fits-all solution. So let me show you what it is, how to use it, and how to set it up, and then we'll see why it's not useful for what we just built. It wouldn't replace what we just built. So in the bottom of the patch, in the toolbars, on the bottom toolbar, the last 2 options, the last 2 buttons, let's see if I can bring this up a bit so you can see it a little bit better. The last 2 buttons look like a keyboard, piano keyboard, and a computer keyboard. And the piano keyboard says assign MIDI map, and the computer keyboard says assign key map. And if we click on one, I'm going to start with the assign MIDI map. What that does is it creates this overlay, and the overlay actually creates a purplish outline around some of the objects. And now any of these objects we can actually really quickly map to our hardware parameters. So for example, I have the master volume slider. I could click on it and select enable for mapping. And once that's selected, it kind of fills in. And then what I can do is with my hardware, I can take any of my dials and move it. And as I do, check out the screen, it's now responding to my dial. So that's super snappy, right? It's way faster and easier to set up than how we set up the K slider. But what I want to point out is that this sort of snappy auto mapping function doesn't work on every object, not on every GUI object. In the K slider, actually, we can't enable it for mapping. So the MIDI mapping overlay is super nice, super sleek, but we still need to know how to bring MIDI data in from the MIDI in and MIDI parse objects. It's still required. And there's another reason too why I still kind of have a preference for MIDI in and MIDI parse over the mapper. And that's because I'm always working in my code thinking about sharing it with the world. That's where I come to Max from. A lot of people come to Max wanting to build patches for their own enjoyment. And in that case, the MIDI mapper is awesome because you're plugging in your keyboard, you're mapping it to your keyboard, and you call it a day. But the problem is that the mappings that it builds stay attached to your hardware. And while I'm working with an Arturia Mini Lab, if I finish mapping this, which I guess I'll save it and I'll share it on Patreon, if you attempted to change that slider in your setup with another piece of hardware, it's not going to work because it's looking for an Arturia Mini Lab. So the advantage to using this setup is that when the patch loads, it's going to look at the computer and say, hey, what does this computer have attached to it? And it will make its own new menu for whatever computer loads this patch. And so it's a much more dynamic, it's a much more versatile solution. It just requires a little bit of additional setup. But the setup is not awful. It's certainly not so much that it like ruins the experience. So this is my preference, but if you need to get something thrown together quickly, the MIDI mapper is awesome, and the key mapper does the same thing, but it maps it to your computer keyboard. So you have a couple of really nice, sleek options and the full package with MIDI in and MIDI parse. Okay, so I didn't quite get as far as I wanted to today. I wanted to make a nice, sleek interface for the ADSR, and I wanted to expand this single oscillator to a collection of oscillators. But I think an hour is plenty, especially for people who have other things to do with their lives. So we'll keep expanding on this on Tuesday. But if anyone has any questions at this point, I'd love to hear what you're working on. I'd love to hear if you have any confusion or hang up around any part of this patch. If the ADSR envelope is still kind of like breaking your brain, we could talk about that more. Any questions about my workflow, anything at all. So Microtonal Trumpet says MIDI in and note in and such only work when I specify my hardware as an argument. The menu for some reason isn't telling MIDI in what my hardware is and how to talk to it. Okay, that's a really interesting problem. You know what it might be, remember that this whole setup requires the load mesh to work, so don't forget to double click the load mesh to get that to populate. That's one thing that may be going on. Another thing, I don't think this is the case, but I know with older systems, older versions of Macs, you would have to have your hardware plugged in when Max opened. So it might be worth taking a minute just to quit Max and open it back up. I hope one of those things gives you the solution you need. And let me know if you copied that code directly out of the help file like I did, because that's another important part of it. Yeah, it is tricky to troubleshoot on here. Yeah, you're welcome. Let's see. Does anyone else have any questions or anything they'd like to ask? about the patch or about anything Max related. Totally happy to chat about whatever. Do a little bit more cleanup while I wait. All right. Well, we didn't make too much of a mess out of this lesson's patch, which will be nice. Okay, so I do have a couple of things. So first, let's go back to microtonal, and then I'll talk to 11 pigs. So microtonal says keyboard isn't working in this patch, but it does in another. The keyboard isn't working, like your hardware keyboard isn't working. So check out the object flow in your other patch and compare them. Try copy pasting some code. Remember that if you're talking about the K slider, we did change the K slider setting in the inspector. But if you're talking about your hardware keyboard, it doesn't make sense that it would work in one but not the other. If you haven't totally closed out of Max yet, try that. The next thing is I would just copy paste the code out of the working patch and see if that works. So 11 Pigs asked a really nice question. How did I end up learning Max? So the history, the backstory for me is that I did my master's at the University of Texas, Austin, where they have an awesome program, an awesome composition program that puts as much sort of emphasis on acoustic composing as electronic composing. And when I came to UT Austin, I had very little experience with electronic composing, but not because I didn't want to. I really, really wanted to get into it. And at the time, I was working in Logic, and a Max class was offered during my first semester as a master's student. And I took it because I did want to know. I was really curious about Max, but just sort of curious. I didn't really think that Max was going to be a critical part of my workflow. In my mind, I was gonna like learn how to build stuff and then maybe use it to make some neat sounds in a couple of pieces here and there. But within maybe like a week or two of classes, I was just hooked. Like it was so much fun, just learning about all of these mechanics of sound design and patching and this notion of like if you understand the science and the code, you can make anything. It just blew my mind. So I was hooked right then and there. And the Max class at UT Austin at that time was a 2-semester class, which was a phenomenal idea because it's very difficult to get a meaningful understanding in one semester. So it was a 2-semester class. Then we had a 3rd semester for jitter, just jitter. And so I got 3 semesters of it. And at the end of my first semester, I had already had a friend commission me for a piece. So I had a commissioned performance at the end of the first semester, which again sort of kept that snowball going of like, oh, I love this. And look, I can make music and I can get music performed with it. And at the end of that first semester, a call went out in the department for a research assistant to do some work in Max with a couple of the faculty. And I jumped at that opportunity. And yeah, so microtonal trumpet, you figured it out. It works now. I had it going into the wrong message inlet. Yeah, story of my life. That just making sure all the inlets are hooked up is a major component. That's why I say copy pasting the code is always a good idea. But so anyways, at the end of my first semester as a grad student, I got this research position where I had the chance to work in collaboration with the University of Porto, Portugal, and things just like kept being more and more fun. I had so many opportunities to work in Max, and it just seemed that the more work I did in Max, the more exciting it became, and the more it just sort of blossomed. open as a program and blossoming potential, and then like blossoming opportunities for me. So um, it was pretty much love at first sight, and it's a relationship that I'm still outstandingly grateful for. Yeah. And you learn as you go, So I began learning with those classes, and then with every other assignment or project that I was given or worked on, I just had to learn more things. And so I did, picking up the help files, picking up um, the reference files, going onto the forums, communicating with other people in the community. It's really the way to go. Yeah, I understand that. So 11 Pigs is saying that it's been obsessed for a while but couldn't find the time to learn. I hear you. I mean, it is hard to. It's a whole world, And I think for a lot of people, one is, yeah, how do you find the time, and two is like, well, where do you start? Yeah. No one else needs the questions. Yeah. So yeah, I'm glad that you were using the quarantine time to get started, and I'm thrilled that you're getting started with us, because it's a blast to get to talk to others and to get to share this information in a way that benefits people. So microtonal trumpet, if no one else has any questions, how do you recommend starting jitter? I'm interested in doing visuals too, but it's a whole other can of worms. Yeah, so that is a tough question. We are going to do a jitter unit next, because I don't want to get too far without touching on jitter. Um, if you don't know where to start, always start with the help files. There are great tutorials. So if I go to help reference and go to the home page, there are jitter tutorials, right? We see a list Maximus P jitter, and just go through them. It's one of the very best ways you can learn. Now, I will say that jitter has changed dramatically over the last several years, and we're going to talk about that when we get to the third unit. When jitter was established, it was not taking advantage of the GPU at all. Everything that it processed on the CPU, which meant that audio and video were sort of competing for the same pipeline and the same resources. And eventually, jitter and C74 embraced OpenGL as a language that gave direct access to the GPU, the graphics processing unit. And OpenGL access to the GPU transformed jitter so that you could do a lot more, and you could scale up the power of what you could do based on the graphics card that you have at your disposal. So over time, C74 has recast jitter objects as jit.gl objects, but they're still sort of catching up. It's trickier than audio. One, because you're working with an additional dimension of data. You have a matrix of information as opposed to a two-dimensional timeline. But on top of that, you're also working with objects that run on the CPU and objects that run on the GPU. So what I would say is start the tutorials to start to wrap your head around jitter, but also look into jit.gl and try to wrap your head around jit.world. Jit.world is a critical component of the modern jitter workflow. Yeah, and if you can't wait, that would be my big recommendation. But that will be the next unit, is an introduction to jitter. Yeah, of course, you're very welcome. Anybody else? Love the questions. I really love the feedback, y'all. All right, so I'm going to go ahead and do my pitching. Like always, remember that I do have Patreon. I'm in the process of ramping it up at this point. There's still more yet to come, but I am not only sharing patches, I am also sharing the previous classes for posterity, because Twitch only keeps them up for so long. And as time goes on, we're going to have multiple units and multiple topics. So Patreon is where you can find those videos and watch them at your leisure, and then grab the patches and reuse them at your leisure. As I continue to ramp up, I'm going to use Patreon to be uploading past classes to YouTube. So they're on YouTube, but they're kept private for my Patreon. And I'm going to keep everything up on Twitch for a little bit, and then I'm going to stick to Patreon because, I do need some financial support structure for the work that goes into this. But there will continue to be the classes for free, and I'm going to continue to ramp up the free classes over time too. And for the people who join me on Patreon, I'll eventually get into things like Patreon exclusive classes. I will have my patrons help me choose the topics for upcoming units, and I'm looking for a lot of fun things to do. I'm probably going to do like extra challenges. So once the class is done, I will come up with alternate concepts, share those as challenges, and then allow you to share your results with me, and we'll actually communicate about them. We'll talk through the patches and see why they didn't work or where you got hung up. So I really want it to be an extension of the sort of conversational and communicative aspects of Twitch, but more custom tailored to what people want to learn. So Patreon's ramping up. Anyone who joins there, it's hugely appreciated. If you don't want to do a reoccurring payment structure, but you still want to support me, there's also the link to PayPal where you can just donate on PayPal at one time. Hugely appreciated. And I've got the Twitter account up. On Twitter, I just post the link to the patches ahead of class time, and then post notices about class beginning. And so it's an easier way to keep track of how things are going to, what things are going to be coming up. Yeah, you're very welcome for the stream, and thank you for joining me. So that's going to wrap it up for tonight. Thank you all again. I hope you have an awesome weekend, and I will see everybody on Tuesday as we dive deeper into building this polyphonic additive synthesizer.